Welcome. We are live. It is Work It Out Wednesday. We will give everybody a minute to join us and we will get started tonight. I am excited for you to be here per usual. We are here live every Wednesday. We will be here live every Wednesday through final exams. And then if you say we want more, we might do this summer too. I'm just going to go ahead while we're waiting for some people to join us. I'm going to write this inequality. So we have been working with inequalities with a group of our seventh graders. And let me tell you, on this state test, if you understand inequalities and equations, your student can get about 4 problems correct. And it's really important that they understand that in an equation, we're balancing both sides, and an equation is about both of the sides equaling each other. And in an inequality, we're making sure that that equation is true. And what do we mean by that is whatever side it says is greater than or equal to, when we put in the number, that it still is true based on our inequality sign. And that's what we're looking for. So we are going to go ahead and solve this one tonight. And the steps are pretty simple. It's just like we do for equations, except we have our inequality sign. And like I do for equations, I like to box my terms that are just consonants, circle my terms that are variables. That way it reminds me which of our things group together. So we have negative 5x plus 4x plus 4 is less than or equal to 12. So let's go here. We have negative 5x plus 4x. That is going to give us a negative x. And then we're just going to rewrite our plus 4 is greater than or equal to 12. And then now remembering our equations. All right, New Jersey, Ohio, thank you for joining us tonight. We are going to subtract by 4 because what we do to one side, we do to the other. And now we get negative x is less than or equal to 8. Alrighty, and because we have a negative here, even though we cannot see it, all right, Charlotte is in the house. It's really an imaginary one, and I know there's some people out here that don't like me to call it an imaginary one, but we don't write the one. It's just kind of known that this is a 1. And our rule that makes inequalities different than equations, and it's because we want to make sure that that is true, is whenever we divide, and so technically we're going to divide by this negative 1 on both sides, or multiply by a negative number, we have to flip this sign. So since we are dividing by this negative 1, which means this really equals a 1, we're going to have x, we're going to flip to greater than or equal to, and that will give us a negative 8. So our solutions, because that means all of these solutions are true, especially since we have this equal sign here, is that x is greater than or equal to negative 8. Any numbers that meet that. So that is our first problem of the night. And thank you for everyone joining us from all over. We are here every Wednesday working out problems, whether they're emailed to us, problems we see from our students, problems you request. And if you have any requests, please feel free to shoot us an email at help@mathematicstutoring.com, and we will be elated to help you. So something else that I would love to show tonight. Well, I need a fresh piece of paper. Here we go. is ordering numbers, rational numbers, from greatest to least. So I am going to do one from one of our previous exams tonight, one of our state exams. So even if you have state problems that you just want to see how did they work that out, we will be working out some of those too. All right, so this is going to be a 6th grade level problem. And so the question asks us to order from least to greatest these numbers here. So 46 over 24, negative 0.0209, negative 1/8, 35 over 52, and negative 1 7/10. I hope you can see all of those numbers. And I'm just going to kind of box them so that we know each of them are separate. Alrighty, so they want us to order these from least to greatest. So I'm going to remind myself that I want to do least to greatest here. That's first of all. So now we know that we are comparing all of these fractions and we have this decimal here that we need to compare. And the fractions, they really don't look like we could tell right now too much of which ones are which. But there's a few things I noticed right off the bat here. So we know, since we're saying the least, we know that's the smallest, right? Well, when I look at our negative numbers, our smallest negative number would be this negative 1 7/10, just off the fact that we have a negative 1 here and none of our other negatives have a whole number. So that is the most negative. So actually that will be our first one right here. Okay. So that's good to know. Then I just know off the top of my head. But if you are a student, you may not know what 1/8 is as a decimal. So we want to figure out which one is smaller, 1/8 or this negative 0.209. So for questions like these, you're using math in the computational sense, but you are also using your reasoning skills here as you do these. So let's turn 1/8 into a decimal, this negative 1/8. And so I'm going to come to the side here, or maybe a little below. And I like to use this method called TIBO, and we'll be using it for a couple of these potentially later, which means top, inside, bottom, outside. And so what do we mean is the top number, so our 1 is on the inside, our bottom number is on the outside, and that's our 8. And we know that 8 can't go into 1, so that is 0 times, and we're going to add a 0. 8 into 10 goes 1 time, and we get a 2, and we can add another 0 here, and we bring that down. 8 into 20 goes 2 times, which is 16. 20 minus 16 is 4, and we can add one more 0, which gives us 40. 8 times 5 gives us 40. So we know, and we know this is negative, so we won't forget that. We have a negative 0.125. So is negative 0.125 bigger or smaller than negative 0? 0.209 or 209 thousandths compared to 125 thousandths. Well, we know that actually the bigger the number or the closer to zero it is, the larger it is. So our next number in our order here would actually be the negative 0.209, and then it would be our negative 0.125 or negative 1/8, however you want to say it. So we've canceled out both of those. And now we are down to two of our improper fractions. So, one improper fraction and then one fraction here. So thinking about that, our improper fraction here means that we have a whole of some type. Well, we know that this doesn't have a whole. So this automatically actually tells us without doing any math that this 35 over 52 is smaller than 46 over 24. Because it's an improper fraction, it means we have at least one whole in there, but this is not. So that means 46 over 24 has to be our largest number. And that is how we can order those. And while that might seem so intimidating to someone at first, with a little logic, you can really get there. All right, I hope everybody is still with us tonight. I would love to hear what people would love to see us work out and do. And if you have any questions live, I will give you all maybe 2 minutes or so if you want to drop any questions to us. And if not, I will do something else tonight. Kimberly, do we have any comments in the chat? No comments. Okay. No worries. No worries at all. Okay. I'm going to take us on down. We're going to hit up some elementary tonight. Let's do some elementary problems. What will they be? Okay. So we're going to do a little equivalent fraction practice. And to be honest, we do a lot of fractions because fractions are something that our students really struggle with or don't understand parts and pieces and which are equivalent and which are not equivalent and things like that. But I will show you a great way to compare if a set of fractions are equivalent or not. And we'll do a few of them. So we're going to do 5/9, 2. All right. So we are going to, can you do fractions 3rd and 4th grade? Yeah. So actually, I had great timing. Thank you, Gorgeous Strand, for that. So here we're going to actually compare these fractions. So we want to know, is 5/9 less than 1/2? And so how we can compare, we actually can do the butterfly method. And let me talk about the why. Why does this method work? It is the assumption that we've done the traditional way, and I'll show the traditional way on another problem, of finding the common denominator using multiplying 2 here and multiplying by 9. And then we can crisscross. So 5 times 2 is 10, 9 times 1 is 9. And because of that, so really this is 10 over 18 and 9 over 18 because it's as if we're multiplying 9 and 2. We can now easily compare these fractions. So 10 over 18 is less than 9 over 18. Well, that's not true. 10 over 18 is bigger. And then so since I showed it with our quote unquote butterfly method, which is just cross multiplying, and whoever has the largest multiplier is the bigger fraction. We're going to do the same thing for this one that's equal. We're going to do a different way for the one that's equal. We're going to find the common denominator. So we have 8. Well, we know that 4 times 2 gives us 8. So we can do the same thing. What we do to the bottom, we do to the top. And so we get 8, 2 8s. So they are equal. So this one is true. Okay. And so I'm going to do the same thing. I'm going to butterfly this one. So we get 24 and we get 20. 24 is greater than 20. That is true. So this means that 6/10 is greater than 2/4. And that also is true if we made a diagram. Your student could actually draw this out and make a model to show that this is true as well. This is just computational. Well, for this one, we're going to go ahead and find our common denominator because I want to show it multiple ways here. So we have 3 and we have 10. And what I like to do, I like to keep it simple on finding the common denominator. Let's just multiply them by each other. And that's essentially what we're doing here. So 3 times 10 and 10 times 3. And what we do to the bottom, we do to the top. So 10 times 2 is 20. 3 times 10 is 30. Is less than 10 times 10 times 3 is 30. 9 times 3 is 27. So it's 20 over 30 less than 27 over 30. That is true. And this is exactly what we're doing here. We're just skipping the step of showing that we're multiplying our denominators. Alrighty. For Gorgeous Strand, she says, can you do fractions? What would you like us to do with fractions? Would you like us to do some addition? I know that was like equivalent fractions or comparing fractions. Thank you. Thank you. Okay, or maybe that was what you were looking for. So that worked out perfectly. Is she saying something else, Kimberly? No. Okay. Cool beans. Let's see what else we're gonna work tonight. Hmm. Okay. Fraction equivalence like 511 equals 0.45, 10 over 22. Okay, so maybe more of changing a fraction into a decimal. We can absolutely show that again real quick. So I will use one of the fractions we did, 5 over 9. And how I help students change their fractions into decimals, we like to use top, inside. Oh, okay. Okay, I got it. So she wants, I'll still show this real quick and then I'll go to the other. Is it a little blurry? What changed? Let me see. I'm not sure. I am so not sure what happened to my camera. Okay, top inside, bottom outside. And so what this is really, it's just reminding us that fractions are really division. And it's reminding us how we set up that division problem. So our 5 goes on the inside and our bottom number 9 goes on the outside. And because 9 can't go into 5, we know we already have a decimal and it will be 0. And we'll add a 0 behind here. And 9 goes into 50 5 times. So 5 times 9 is 45. If you have a student who is not really abreast on their multiplication facts, they can absolutely do a T-chart to help them solve that problem. And then since we still have something remaining, we're going to add another 0, and that would be 5 again. Oh, and it looks like we have a repeater. So if it repeats, that means it continually goes on and on and on of the same pattern. And this is just how we turn a fraction into a decimal. And then I am going to do Gorgeous Strand's problem really quick on fraction equivalence. So what it happens when we have 5 over 11 is equal to 10 over 22. And so if we're trying to see if they're equal, or you can see what factor is making them equal. This goes back to how I showed it. We can either cross multiply or we can find the common denominators for this. And when I just looking at this, I would totally find the common denominator because it'll give you larger numbers cross multiplying. So we know 22, well, we know 11 times 2 is equal to 22. So then what we do to the top, we do to the bottom, and we get 10 over 22 is equal to 10 over 22. So they are equivalent. And so this is a good one when you got to make a choice of whether you want to do the butterfly method or whether you want to stick to the basics of finding a common denominator. And this was a really good one to just stick to the basics because you'll end up multiplying more. Alrighty, thank you so much for participating and asking a question. We really appreciate it. And we are coming to a close tonight. We now we do 30 minutes on Instagram and we do 30 minutes on TikTok on Wednesdays. So if you do want to continue with us, we can absolutely catch us on TikTok from 7:30 to 8 o'clock. If you love what we're doing and you want to support this content and this work, we have a Buy Me a Coffee link on the screen as well as in our Instagram profile. Please feel free to buy us a coffee and we will be back here next Wednesday. Okay, let me do this one more. question here. So if you have 1/2 is equal to 3 over x, how does he get that? Okay, great question. So, and I want to make sure, was there anything else to this problem, or is that it? Okay, good. So actually what he can do is cross multiply. So back to that butterfly, or we could call this a cross product. So we know that x times 1 will just give us x is equal to 2 times 3, which gives us 6. And so think about it. I'm going to rewrite it. 1/2 is equal to 3/6. Is that true? That absolutely is true, because we know 2 times 3 is 6, and 3 times 1 is 3. So 3/6 is equal to 3/6. Oh, let me move that up. So because they're equivalent, you can do cross product multiplication, or you could call it the butterfly method. That is what allows this to work. And this is a great skill, even though this is like a 3rd and 4th grade skill. My 7th graders use this right now when we are doing ratios of, like, you have 2 boys to 4 girls. This is what they're doing and why it works, because it's really about equivalent fractions. So this is a great skill for your students to understand now, because it does show up later. Hope that helped. Again, join us on TikTok Live for the next 30 minutes. We will be doing a session. We will see you next time. Bye-bye.